Determine the real solutions to the system of nonlinear equations. So we have x squared plus y squared equals 16, y squared minus 3x equals 16, and we have a circle, and we have a squared on the y, not on the x, and this is going to be a parabola, but it's not one that we're used to because we normally have the squared on the x and not on the y. So this is going to be a sideways parabola. So if we were to draw a circle and a parabola, this is one way we could draw it. We have 4 intersection points. That's a possibility of 4 solutions. We could also draw to where the vertex of the parabola just touches one side. That would give us 3 solutions instead of 4. We could have the vertex of the circle being, or the vertex of the parabola being inside the circle and have 2 solutions. We could have the vertex of the parabola just touching the circle like this. That would just be 1 solution, or they could totally miss each other and you would have no solution in that case. So I'm going to try to solve this system with elimination. And when you solve by elimination, you try to add the equations together so that one of the variables eliminate. When I look at this, I can see that we have y squareds in both equations. As far as the x's go, one x is a squared and one is x to the first power. So I can't eliminate x in this equation because the variable x is not like terms in both of those equations. So if I'm going to use elimination, I have to eliminate the y's. So I already have the equal sign lined up. You can see the equal sign is lined up with my equations, but I want to rearrange the terms a little bit so that I have the like terms lined up. So I can do this. I would have x squared plus y squared equals 16. I'd like to line up the y squared here and the minus 3x equals 16. So now my y squareds are lined up. Kind of left a blank space. Maybe I could show it a little bit better. So my x squareds don't have any like terms. My linear x term doesn't have any like terms, but I've lined up the y squareds because those are like terms. Okay. All right, now what I want is the y squareds to eliminate. I need to be able to add the equations together and for them to cancel out. So I need one of them to be positive and one of them to be negative. They already have a coefficient of 1, so if I just make one positive and one negative, then when I add, they will eliminate. So let me multiply the second equation by a negative 1. So my first equation doesn't change, x squared plus 1y squared equals 16. My second equation becomes that would be a positive 3x minus y squared equals negative 16. Now I'm going to add the equations together to get x squared plus 3x equals 0. I can factor out an x, and that leaves me with the x plus 3. I can set each factor equal to 0 and get x equals 0 and x equals negative 3. So I have the start of my ordered pair solutions. Let's find the y-coordinates of those solutions. I can substitute these x's back into any equation with two variables, so I'll use this one here, y squared minus 3x equals 16. That's y, if my x is 0, that's y squared minus 3 times 0 equals 16. Y squared equals 16. I'll square root both sides to get y equals plus or minus 4. So my x was 0 and I got a y of plus and minus 4. So that gives me two ordered pairs. Let's do the same thing with x equals negative 3. That's y squared minus 3 times negative 3 equals 16. Y squared plus 9 equals 16. I'll subtract 9 to get y squared equals 7. Square root both sides. And y equals plus or minus square root 7. So we had x equals negative 3, and we got plus and minus square root of 7. So we get two more solutions, two more ordered pairs. So we have four solutions, 0, 4, 0, negative 4, negative 3 square root of 7, negative 3 negative square root of 7. Thank you for checking out my videos. Have a great day.